Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to have x minus 12 times x plus 7. For the math knowledge question, we want to find the volume of the figure. So for the cylinder, it's just going to be area of the base, pi r squared, times the height. Now for the hemisphere, that is half of a sphere. You may or may not know that formula. We haven't learned it this year, but it's 4/3 pi r cubed. So you may have seen that somewhere else. You may have looked it up, but that's the formula we want to use. So our radius is 10, and our height is 25. And then 1/2 4/3 pi 10 cubed. And so if you plug that into your calculator, you should get about 9,900, sorry. You should get 9,948. And it says which one is the closest. So that's the answer you would pick. Okay, so we are going to be looking at lesson 32 today. It's the altitudes and medians of triangles. So hopefully you'll understand how those work after this lesson. So median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. And then the centroid of a triangle is the point of concurrency of the three medians of a triangle. So point of concurrency just means where they all three intersect. So there's the picture. These are our medians. They all start at a vertex and go to the midpoint of the opposite side. So those three lines are medians. And then this point here is the centroid, and that's where the three medians intersect. So you need to learn that the medians intersect and form the centroid. The centroid is also called the center of gravity, and it's the point where all three medians intersect, and it is always inside of your triangle. It is always going to be on the inside. This is the centroid theorem, Theorem 32.1. Your centroid is always located 2/3 of the distance from each vertex to the midpoint of the opposite side. So in this triangle, let's look at CPZ. CP is 2/3 of the whole thing. So this part is 2/3, and then this part over here is 1/3. The 2/3 is always the one that starts at the vertex and goes to the centroid. So if you look at another median, this part here is the 2/3, and this part here is the 1/3. And then if you look at the other one, AP is 2/3 of the whole thing, and so this other part is the 1/3. So if y'all need to pause the video and write that down, y'all can. I'm about to go on to an example. So we want to find x here. So it tells us that D is our centroid, and it says CD is x plus 4, and CE, that's the whole thing, is 30. So we need to make our formula first. So CD is 2/3 of the whole thing, which is CE. So that's your formula you want to make. This part here is 2/3 of the total. So CD is x plus 4, and 2/3 of 30 is 20. So x would equal 16. So that would be your value there. If you look over here, if this whole thing is 30, 2/3 of 30 is 20, and 1/3 would be 10. So this length here would be 10, and then this length here would be 20. Looking at another example, we want to find the centroid of our triangle. So there's a shortcut that you can do on this one, and it's super duper easy. To find your centroid, you're going to say your x1, your x2, and your x3. Add those together and divide by 3. y1 plus y2 plus y3 and divide by 3. That's the formula you need to do. So I would write it down. It makes it a lot easier to find your centroid. So our x values are -2, 2, and 1. And our y values are 2, 2, and -2. So if you add and divide by 3, you should get 1/3, 2/3. So that would be your answer for that one. Okay. Now we're going to look at altitudes and orthocenters. So the altitude of a triangle, we've talked about that before. It is always perpendicular going from a vertex to the side opposite it. So if we have a triangle, the altitude would be this line here. If you have a right triangle, then the altitude coming from this vertex would be this side. And if you have an obtuse triangle, your altitude is going to come down and it's going to be perpendicular, and you have to extend your side. But those are your altitudes for different triangles. You can draw 3 altitudes, and the orthocenter is where the 3 of those are going to intersect. So you need to learn altitude and orthocenter. Those are related. So medians intersect at the centroid, altitudes intersect at your orthocenter. And there's an example of your orthocenter. It's where your 3 altitudes are going to intersect. So we're going to draw an acute triangle, a right triangle, and an obtuse triangle. And then we're going to sketch the altitudes of each and find their orthocenters. So for an acute triangle, you all go ahead and try and draw your 3 altitudes. So this one would go there, maybe. And that one would go there. And then there's that one. And so that would be your orthocenter. Okay. Let's try a right triangle. So y'all see if you can maybe try and draw your 3 altitudes by yourself. So the first one is going to be here, or one of them is going to be here, because that's going to be perpendicular. If we come from this vertex, it's going to be perpendicular. And if we come from this vertex, it's going to go right there. Now, the 3 intersect here at the right angle. So that's how that one would work. And now we need to do an obtuse triangle. And this is the one that's the hardest for me to draw just because I don't have a ruler to go with this tablet. So it makes it a little bit more difficult to do. So you start at a vertex, and I'm going to go perpendicular. Okay, so there's that one. Now for this next vertex, when I come down, I have to extend this side to be able to make it perpendicular. Okay. And then for this next one, starting here, it is going to be perpendicular to this side over here. So I have to extend it as well. And so right now they aren't intersecting. We've got one here, and one here. But if you extend them, well, they should all intersect at this point out here. And so that would be your orthocenter. So is the orthocenter always in the interior of your triangle? No. For an acute triangle, it's inside. For a right triangle, it's on the right angle. And for an obtuse triangle, it's outside. So that's how your orthocenters work. Looking at this one, we want to find the center of gravity for our piece of art. So first thing we need to do is graph it. So 0, 8, 6, 4, and 3, 0. And then that's our triangle. Now, what is the center of gravity? Am I looking for the centroid, or am I looking for the orthocenter? I'm looking for the centroid. So I actually don't need to do the graph. I don't need to use that. I can just do my shortcut formula. Add my x's and divide by 3, and add my y's and divide by 3. And so if you add and divide by 3, you should get 9, not 9, 3 and 4. So that would be your center of gravity. So that's all you would have to do there. You do need to know that the center of gravity is the centroid, because it didn't tell you you were looking for the centroid. You had to know that was the centroid. Okay, so now let's look at some practice problems. So y'all pause the video and try this one by yourself. So it tells us that AD is 5, and then EO is 4.2. We want to find the length of OD. So OD is 1/3 of the whole thing. So 1/3 of 5 is 5/3, which just says to the nearest hundred. So make it a decimal. So 1.67. And then it wants us to find the length of BE. So this is the 1/3 part. This part is the 2/3. So it's twice as much as this. So if this is 4.2, this one is going to be 8.4. And so BE is going to be 4.2 plus 8.4, which is 12.6. So that would be your answer for that one. Looking at this next one, again, y'all pause the video, try this one by yourself, and then unpause the video and I'll go over it. So on this one, we're looking for the centroid. So we actually don't need to worry about graphing it unless you just want to try and graph it to find the centroid. You can use your little formula, and we can do our x's, so -9 plus -1 plus -5, and divide by 3, and then 1 plus 5 plus 9, and divide by 3. So if you add those together, you get -15/3, which is -5, and you get +15/3, which is +5. So that's your centroid. If you are interested in looking at how to find the centroid using a graph, you can look on page 206 in your book, and they help you go over that. You can find the midpoint of each side, and then you can figure out where they intersect. It requires a little bit more work, but it is possible to do it that way. It's not terribly difficult. It just takes a little bit longer. This method here is definitely more quick, much more quickly to work through. Okay, so let's see if y'all can do these two. So y'all pause the video real quick and go over them, and then unpause the video and I'll tell you the answers. So for the orthocenter of a right triangle, it is always located at the right angle. It wants to know if we have medians of 3.6, 6.9, and 4.5, how far is the centroid from each vertex? Well, the centroid is always 2/3 from the vertex. So you're just going to say 2/3 times 3.6. So that'd be 2.4 inches. 2/3 times 6.9 would be 4.6 inches. And then 2/3 times 4.5 would be 3 inches. So that would be how far it is from each vertex. Okay, so now we're going to look at the challenge question. So it tells us line M and N contain medians, and we want to determine X and Y. So y'all pause the video and try this one, and then unpause the video and I'll go over it. So on this one, this is the 2/3 and this is the 1/3. So if this is 1/3 and it's 3.6, multiplied by 2 would give you 7.2 for this 2y plus 4. So 2y plus 4 would have to equal 7.2. And so if you subtract 4, 2y would equal 3.2. And then if you divide by 2, y would be 1.6. For the x value, this is your 1/3 here, and this is your 2/3. So x times 2 is going to equal 3x minus 2.4, because take this side and if you double it, it'll be the same as this one over here. So then that means that x would equal 2.4. Okay, so that would be your x and your y values. So you really need to learn that the centroid is where your medians intersect and your orthocenter is where your altitudes intersect. We will have another lesson on 2 other points of concurrency, and then one of your projects this semester is going to be on the 4 points of concurrency, and you have to know the difference between them. So make sure that you practice learning which one is which, because we're only dealing with half of them right now. Your homework is 1 through 30, so make sure y'all do those tonight so we can go over any questions you have tomorrow.